All right. Welcome everyone to Polkadot Deep Dives. This session is on storage migrations. Will be presented by myself and Hector, who will be walking us through the demo. So let's begin. So the objective is to explain migrations as an essential part of the runtime migration, the runtime upgrade procedure. So seasoned substrate developers will be very familiar with this concept of forkless updates, and storage migrations are an integral part of it. So I'll be covering the conceptual part of storage migrations, and Hector will be showing us a demo with how to set up the migration and how to test a multi-block migration. So yeah, let's begin with that. So first off, the preload runtime upgrades. What are they? So as I said, forkless upgrades are a very big feature in Substrate, and every chain built with Substrate stores their runtime code as this. It compiles the runtime code to WASM, and then it sets a key. So the code key under the on-chain database, it stores the WASM blob under that code key. And so whenever you want to do a runtime upgrade, you basically overwrite this value. But there is a problem. What is that problem? So let's first revisit the definition of runtime. So runtime is defined as the state transition function, right? So the logic that allows you to go from one state to another state, one valid state to the next valid state. But the runtime also contains data type definitions. Your palettes that use storage items, they are also defined as part of the runtime. So just by upgrading your runtime code, you also uh, invalidate some of these data schemas, and you need to take care of that. So that's where storage migration comes in. Now, as I said earlier, that data types are this they go along with the runtime. So there needs to be this translation between the previous state and the new state. And so the storage migrations are basically these procedures. They are this umbrella term for all these procedures that take the blockchain state from the old type to the new type. Okay. Mm, yeah, and what happens if you skip a storage migration? Well, you basically end up misinterpreting existing on-chain data. Therefore, your chain becomes mangled. It enters into this mangled state, and that's bad. That's bad for your chain. So, the question that arises now, that how can I determine if I need a storage migration? So there are, we have listed a few scenarios here for you to look at, but the general rule is whenever there is a change in the interpretation or layout of existing data, you need a storage migration. So let's look at a couple of scenarios here. So what about adding and removing extrinsics during a runtime upgrade? Does it warrant a storage migration? Obviously, no, because extrinsics are pure functions, and pure functions, they hopefully they don't come with a dependency on existing data. So no, you don't need a storage migration in that case. What about existing storage maps that you may have? Storage maps, storage values. What about them? So of course, if you change them, storage items, if you reorder their fields or you change the data type of any field, you will be needing a storage migration. And you would have to tell your chain, okay, this was my previous type. Now use this function to transform it into the script. Plus, even if you notice here that I include this reordering, what does that mean? So if you have a struct with various fields and you go around changing the order of those fields, the way scale encoding and decoding work is that even though your encoded bytes remain the same, their positions change, and that needs a storage migration. So in terms of Rust, nothing has changed, but in terms of the encoding and decoding, it has changed. So, in other words, the serialization and deserialization of your data type. Removal of a palette or storage item. Now, you got rid of a palette. Goes without saying that the storage items that were under that palette prefix, they are still on chain, causing state load. So if you care about optimization, you may want to write a migration to get rid of those values under those keys. Same with any storage migration. Let's say you get rid of a storage item. Uh, if you had a lot of activity within that storage item, it's taking up space, and it makes sense to get rid of it. Here I've linked a pull request that was made to palette contracts. They actually removed a storage item, which ended up clearing a lot of space, and that proved to have performance benefits for everything using palette contracts. Adding a new storage item. You added a new storage item in your chain using the palette storage macro, storage alias. Consider for a moment what happens when you just define the storage item. You're not writing anything to chain. On the runtime upgrade, when you include your new extrinsic, you won't be writing any data, hopefully, to that storage item. So it doesn't really make sense. Like, even if you write data to your new storage item, it's still a new storage item. So probably you don't need to think about storage migration. So these are just some of the scenarios that are listed here. There could be multiple scenarios that I haven't covered here, but this is the general idea. Moving on, let's now talk about the mechanics of storage migration. So this when you go through the substrate documentation, you'll find this storage version defined in palettes that are undergoing this migration procedure. Now, the way to understand storage migration is it's a guard. It's a guard that says that, okay, this palette is at version 2 or version X or version X plus 1 rather. And if the frame on runtime upgrade hook detects a palette at storage version X, then run the migration for X plus 1. And this code, this logic that I described can be done manually, or you can use version runtime upgrades, which is another runtime upgrade hook that does this process for you automatically, checking the storage versions across runtimes. And so, beside that, you can see that the logic that I just described, like if on-chain version is less than 2, do this, else don't do anything. So if you detect a chain running behind your current storage version, run the migration, and consequently accrue the weight that was consumed, and also write to the storage version value that you have defined here, write that you have updated your chain. So you don't want to run the migration twice, because that can have unintended effects, basically. uh, so yeah, let's look at the on runtime upgrade. Now, the migration is triggered by the on runtime upgrade hook, which runs before the on initialize hook. So if you are familiar with substrate, these hooks are bits of logic that run uh, on when certain conditions are met. You have on initialize when a new block is being constructed. You have on finalize when you have done executing the extrinsics. Similarly, this on runtime upgrade will take preference over everything. And so the code you write in on runtime upgrade, you need to make sure that you need to be mindful about the weight that it's using, because what happens if you write some heavy computation and it's a parachain? What happens then? You end up breaking your chain. So if you're doing a complex migration, which should span multiple blocks, because one block is not sufficient, you want to implement a multi-block strategy. You want to divide the migration into steps, and just like the check for storage version, you need to have certain checks in place that check whether the migration has completed, whether the migration process should stop. And what you can generally do is you can make use of hooks like on initialize to perform these sorts of big uh, migrations. So here you can see the trait. It has a few methods that are also feature gated. So pre-upgrade and post-upgrade are valuable for testing. So if you are a watcher of the deep dive series, you may have already watched the try runtime deep dive. And in that try runtime deep dive, what basically try runtime allows you to do is it allows you to try a new runtime with the live chain state. And what does that mean? That means that you can test your migrations right there or there. You can import state, you can perform the new runtime upgrade, and then you can run your migrations and then test it in the post upgrade hook to see that everything matches your desired outcome. Now, obviously, this is not uh, in the real world. You don't just want to rely on try runtime. This is a good, um, uh, how do I say it? It's a good indicator that what you're trying to migrate will work, the weights and everything else. But the real world is just chaos, and you might want to try it out on a test network just to be extra safe, especially if it's a parachain. So now also try runtime provides you with this try state hook, which doesn't consume, which is executed in a non-consensus code path. So you can perform very heavy computations. I'm saying very heavy. You can perform all kinds of computations in tri-state to check whether the migration went in successfully. So these are the tools at your disposal for testing the correct storage migration. Of course, you can also rely on writing tests, but this is the canonical way of doing it. uh, Migration ordering. Now, it may happen that certain palettes in your runtime are coupled with each other, or that certain palettes need information from another palette. And in that case, you may want to impose custom ordering. Right here, you can see a code snippet where we run the balances upgrade, then we run the staking upgrade, and finally, we run the accounts upgrade. And what you can do is basically when you're writing your migration, you can implement the on runtime trait for your custom migration struct and have it run in whichever order you want. Usually, the order is the reverse, like how you define it in your construct runtime. It goes in the reverse direction. But if needed, you have the option of writing a custom struct, implement on runtime on it, and then include that on your frame executive type, so that that runs regardless of what is the default provided here. Now, obviously, a talk on migrations isn't complete without talking about utilities available to you to do migrations. Maybe you want to change the prefix. Maybe you want to rename the palette and move all storage items across. Maybe you want to insert certain values into certain keys from another palette. All kinds of things can be important to your use case. And so we have this, I have shared a link here, which is under frame support storage migration, which gives you a list of common utilities. Let's just go over a few. So this one, put storage value, takes the module name, takes the storage item, takes the value, takes the hash, which is the key hash, and just puts the value that you provide into that storage item. Move prefix. You want to change the palette prefix. You provided the from and to prefixes, and it will do it for you. So I urge everyone to check this link out, because there are like really good utilities in here that you can make use of. Obviously, there's also some unsafe methods, like within frame support storage. You'll find this unhashed method, which is marked as unsafe, because it allows you to arbitrarily insert keys, I guess. um, those practices should be avoided unless you know what you're doing, else you risk mangling the chain state. Um, Also, it's helpful to know that the palette storages always start with the palette name and the 2x of palette name and 2x hash of the storage name, a concatenation of them both. So that makes it possible to find which storage items you're looking for and then insert new values into it as you see fit. Um, so, what are the frequently asked questions about migrations? So, what if I'm making a big jump in Polkadot versions? So, let's say you're on 9.30 and you want to go to V1. Uh, Doing just a runtime upgrade, as we have emphasized, is not sufficient. You need to look at the pull requests, basically, that happened within the for the palettes that happened within those versions, and include their migrations. So there are two strategies. The one is this breaking up, going from each version one by one, which can be time consuming, as you can imagine, because if you're using democracy for handling these runtime upgrades, then you have to essentially wait until that proposal is voted on and then included, and then you write your new runtime again and then put it to through another democracy process. Could be lengthy. So the second strategy is about this. What if you try to go about it smartly? So let's say instead of going from state A to B to C, you go from directly from state A to C. And this is possible more often than you think. So it could be that no new information was added within those intermediate steps, which makes this transition from step A to step C or D uh, just a one shot process. And so by including the migration files from the frame palettes and then um, making certain modifications to it, just maybe if you do everything right, you can end up in just a one shot migration step from a very old version of Polkadot to a very new version. When I say Polkadot, I mean the substrate dependencies, the Cumulus dependencies, the Polkadot dependencies. If you're running a parachain, you usually pull this from three separate repositories. Now we have the Polkadot SDK, so it's all in one place. But if you're behind Polkadot V1, you need to consider all these separate migrations and be smart about it. You need to make a analysis on the cumulative differences and then go about it. Uh, what about migrating frame palettes? So you may have a chain where you're using frame palettes, right? Um, that's the majority of the cases that I can think of. And frame palettes also, like the frame system, can undergo a storage migration. Palette balances can undergo system storage migration. In that case, you need to include those migrations within your chain as well. So it's not like you just need to think about your palettes. You also need to think about frame and other dependencies that you may have. And usually in the substrate repo, these storage migrations were labeled with this E star, E0, or E1 runtime migration. You could search for this label and, oops, you could search for this and easily figure out, okay, which PRs are relevant to my code base that I need to include. And yeah, as it said, the code for the migration is already provided within the upgrades, by within Substrate itself. So you just need to include them as part of your migration process. And for the new Polkadot SDK, there is no such label, as these labels have been deprecated now. So you'll need to rely on the change logs for now. And the PRA team, or the Polkadot release analysis that comes out on Polkadot forums, they include, whenever there is a new storage migration, they do make a note of it. So that could be an important source of information when you need to migrate. Finally, multi-block migrations. What about multi-block migrations? So it typically happens that uh, trivial migrations only require a single block, but most migrations are spanning over multiple blocks. A million keys, let's say, you are translating a million keys from some old data type to a new data type. In that case, there is no canonical way yet, but the general idea is that you need to perform the computation using hooks, using a combination of hooks, maybe on initialize or maybe something else, and on idle is another candidate. And and you can do it eagerly or lazily. Lazily just means like when you access a certain key, you trigger a migration right there and there. So you need to respect the single block limit. Like you always need to keep some space for extrinsics. You don't want to stop your chain functionality just by performing a storage migration, right? So you need to be mindful of these factors. And there are a couple of sources, palette XCM, palette contracts. These two examples in particular, the links are here. You can, sorry, these links are not for palette XCM and palette contracts. My bad. So palette XCM and palette contracts, they have two strategy. They have employed two strategies where they run these migrations over multiple blocks, and they keep track of their weight. So that's the only principle that you need to keep in mind. And these links, this issue and this PR that I've included, this actually showcases a new palette that's under development that will allow you to, in most cases, allow you to perform these non-trivial multi-block storage migrations very easily. At least that's the aim. Also, for the demo, we have this multi-block migration for you, so you can get a better feel for it practically. Finally, a bit of historical aside. So, if you have looked at the runtime code, you might have looked at this state version field. So, before 9.16, the state version used to be 0, and the try format, which is basically a data structure abstraction that sits between the runtime and overlay structures and your key value database, that was optimized or transformed to make it more POV friendly. And so that entailed a storage migration, because now you're changing the try format, and obviously you need a storage migration. So every Polkadot client after 9.16 has included this state version 1, which basically says that run this chain in hybrid mode. And it uses something called lazy migration, uh, something we touched in the earlier slide. So it will try to do this state tree migration on the fly when it's needed. And it's a very detailed topic, certainly beyond the scope of this deep dive for which I've included a link here by the core engineers, so you can read more if you're interested. And yeah, now I'll pass the floor to Hector, who will show us a multi-block and also testing a storage migration. So yeah, Hector, the floor is yours.
Okay, thank you very much, Avi. Great presentation. All right, so let's go into to do a code walkthrough and also the demo at the same time. Okay, so for this demo, we were going to use our well-known and beloved project called Trappist. So I suspect like you know it already. So basically, Trappist is a parching. So what we'll do is like do a migration over the Unix palette, right? This previous palette to the NFT, which was like the say NFT version 1 palette. Okay, so I forked the palette Unix to make my own version of it, make some changes, and do the migration. Okay, so super simple. What are we going to do? It's a simple change, right? So we don't have to worry about too much in the migration, but this is just for showing you how to basically how to easily do a migration, right? So if you remember this like a storage item which is called item metadata of, okay, and based on is a storage double map, and based on these two keys you stored this struct, which is the item metadata, which is here. So the original implementation is up to here, right? And what I will do is just adding a name, okay, to this like metadata. It's not a real example. It's just to add like a new field. But as this is a new field, just adding like a default or something should be enough, right? So I have a migration created here. So I basically create this old item metadata struct like holds or represents like the current state. So basically the storage items contains this struct, right? Contains this struct definition. And yeah, basically this is very simple, right? I mean, it's a simple migration, so yeah, not too much big deals with this. So if first of all I use the on runtime upgrade, I implement the on runtime upgrade trait, and I basically do an implementation on the on runtime upgrade, right? As basically Avi was like explaining. Okay, so this is simple. I at the moment the chain is running with the version 0. There is a storage version 0, right? So I get a counting here on translated. I get the this method, which is the translate, right? Basically, if you want to do a translation on a storage items in the migration, you need to basically rely on the translate method that the storage level map API offers, right? So super simple. I call this translate, okay? I put the previous version, so the current version of the struct, right? And then what I will do is, basically migrate to the new version of it by adding the default name, okay? So this is a simple migration. This is like one read and one write. So we already know, okay, like the how many reads and writes. So once we have the migration here, so in every cycle, right, of this read, in this iteration, I'm basically incrementing, okay, the quantity of reads and writes. So let's suppose like that I have, I don't know, 100 metadata items. So it's just a matter of increment, this by one, and then here and in the end, I will like return the amount of read and writes based on the couple of iterations that I did. So this is super simple, right? Nothing to worry about it. So yeah, everything is here. So once these iterations are already done and I have the amount of translated items here, I just update the new version, and then I return the quantity of read and writes based on the logic I mentioned. So how do you do this? Okay, the next step is like you go to the runtime. Okay, sorry, this is not the runtime. This is the runtime. So you go to the executive palette. Okay, and here this one is for migrations. You can like provide the migrations in this part. So I'm basically here adding my migration. Okay, so do not forget also to trigger the migration to upgrade or to change the spec the spec version. This is like the runtime version from the chain. If you don't upgrade, if you don't change this value by a bigger one, basically the runtime upgrade will not happen. Okay, so I will rely on a video to do the demo. You will understand why I'm using a video for the demo in a few moments. So I have this running chain. If you can see here, Trap is running on the original version without the change. And we have basically uploaded like a lot of items, right? So if we inspect how many instance metadata we have, so we have per collection around like 2,500, okay, items. So if you see like, you can see like we have like a couple of thousands, NFTs already. And as we have like basically, let me go back to it. So basically we have around like 15 collections, okay, with 2,500. So it's like, around, it's more than 30,000 items. But in this migration, we shouldn't, worry about it because it's just adding a new value, okay? So you can see that this metadata contains like this data, which is around like 40 something characters, okay? So basically when we do the runtime upgrade, which is what we are going to do here, you will see like, this migration will be triggered, right? So I'm performing here in the upgrade, super nice. Okay, so I provide the runtime, the wasm block to authorize it. First, you need to authorize it, and then you need to enact it. There's a lot of documentation about this, and this is kind of related to runtime upgrade, but we are going to check the storage migration. So we received the upgrade authorized, so it means like we are not able to enact the runtime upgrade, but uploading the wasm file and basically enacting the the upgrade. So let's wait to it. And here we should like receive the event, like the validation store, right? Was like the validation function was stored. That means like the runtime, the runtime is on the storage, and now it's waiting for activated. So that is what we have. We have the events where it says like the validation function was stored, and when it's applied, which is like it says, okay, this is now the new runtime and it starts running, with this version, we should see the logs for the migration. Okay, so let's wait until that happens. It should be like very, very soon. I can like forward this a little bit. So we can see there like the validation indeed, the validation function was applied. Okay, and now let's see on logs. We need to wait until it appears. You will see like a message saying like, yes, we detected an storage migration that was from the version 0 to the version 1. Oh in this case, here we see like the migration was applied successfully. Because if we go back to the, to the code, once everything of this is ready, I logged that the migration was like ready. Okay, so I should wait until like more blocks are produced, and we can go and check the status, right? But what's happening? Yeah, but all right. So I don't know if you check this, right? Basically, I was acting the whole time for this demo. Okay, everything I did was wrong. Okay, so far everything I presented, don't do it. What it's saying right there, okay, is that the candidate block that the parachain is trying to produce is basically discarded because the block production is taking too long, right? So if you see here the counter, the parachain is not producing blocks. Why? Because the migration is taking a lot of time to complete. So it's exceeding the available time for the execution. So if you go, for example, to the relay chain, right, and you go to parachains, boom, you will see like your parachain is bricked. Okay, so yeah, as I said before, I was pretending like this was the right way, and I was like trying to act like all of the things like you don't have to do when you do a migration. Okay, so a lot of things were wrong here. So for example, I'm assuming the amount of quantities of read and writes. Okay, basically I don't know, maybe this is more, right? We don't know honestly how many like read and writes these like whole loops execute, right? Then I'm not sure the actual weight. So for example, this migration exceed the time. Okay, so it was like much more than the block, the available time execution, you know, for a block. So yeah, this was clearly wrong. There is also like unsafe math here. So I try to, I don't know, make the worst migration possible. Okay, and what I wanted to show is like when you assume things, this is basically what happens. Your parachain gets bricked. Also, super important, at any point in time, I mentioned about testing. I didn't rely on trying runtime. I didn't do a fork locally. I didn't do anything, right? So this is a whole failure. You shouldn't do it like this. So for doing a proper migration, I mean, for example, Avi, before he was speaking about like multi-block migrations and so on, right? Uh, I said when I started the demo, like we have uploaded like thousands of items. Okay. So if you have like a big amount of items, at least you should think or you should handle the possibility that one block is not enough. Okay. It depends on your use case if you need to pause the transactions or not for your palette, right? If you are like, let's say, during your migration, okay, there is an incoming transaction that tries to modify an existing storage, that could basically be a problem. So it depends on your use case, but it's recommended that you put your chaining in kind of maintenance mode, right? So there are not like incoming transactions that can basically change what you are, change the storage items like you are migrating. So before starting and showing how is like the right way or the right approach, I would like to basically show you a couple of ongoing right efforts like is that are going on. So first of all, there is this issue like Gav put like in March, and basically here he's saying like he wants to have a palette, right, with well, it's not he wants, right, of course, like he's proposing based on like ideas or proposals coming, you know, from the ecosystem, because like this multi-block migration is something like it started to be discussed like I read some entries in the in Subexchange like last year, right? Since like almost 2 years ago, this is like a current, you know, conversation. And for example, the Moonbeam team, they have a very, very nice, you know, palette, okay, that basically they are handling migrations, how to handle migration, right? And they combine this concept of a maintenance mode. So they were doing, they were taking into account this. But this is interesting because like here is like explain the, for example, the concept of a cursor, right? The cursor is like you have a set of items, and in a cursor you're saying from this to this, and then in the next block you are starting migrating from when you ended, right, in the previous block, and until you finished, right? Until you finish, like the cursor keeps like going through all the items. I recommend you to read this. Okay. Another thing like is good to know and to use in this demo, the one that's supposed to be the right one. I will not basically use these palettes, but Safe Mode and T-Expose are like two new palettes that were introduced in Frame, and you can use it to basically stop your operations, right, and do like a migration in a really safe mode or safe way. Another thing, this is something like was introduced a couple of months ago. It's kind of newish, right? And is the version runtime upgrade. This is a structure like, for example, allows you to says from this runtime version to this runtime version, this migration needs to run. Okay, so basically, as Abby was saying, like you don't rely on the storage versions in the palette, or like, for example, if you forgot to remove your migration in the next like runtime upgrade, this new struct is taking that into account. So there are examples. For example, there is an example here of a usage for the demo that I will show, and the code walkthrough that we will do for like the right way to do it. I didn't implement this, but for the future, yes, I mean, this is a must, right? Also, well, here in this is another PR where like Liam is implementing like good practices for the usage of the version in migration. Okay, so if we go back to the code, it's this one. Okay, let me. Okay. Proper migration. All right. Okay, good. So something to let you know is like, that new migration palette that is being discussed here is not ready yet. All right. But there to showing something like is much better of, the failed migration I did, the option, and, the alternative, which a much better alternative to the failed migration I did. We can like use the current migration framework like Palette Contracts is doing. And my assumption is like, is going to be very much similar, right, to the result of this issue, right? Because this is implementing a cursor already, is checking like the benchmarks. So basically what we did, okay, to show, or to like to show the flavor of how like these migrations would look like multi-block migration framework would look like, we basically brought the framework that the Palette Contracts implemented for handling multi-block migrations, and we put it in the Unix palette. All right. So this migration framework, I mean, I call it framework, right? Because even if it is like a module, it has like kind of a framework, mind model, right? So you have a migration step trait where you, for example, this trait needs to handle the max weight, right, from the steps, and you will see now what a step is. And then here, this steps is basically, the like amount of blocks, right, that is going to take to do this migration. So each step is a set of items being migrated, right? And there is an integrity test, which is basically taking, the maximum block amount, the size and time. So basically, yeah, the max weight for the block, and is comparing and saying if your migration, right, is if your step is not like exceeding the available, weight for the block. So something very cool is like you could like for using this framework and doing the migration, you just need to implement this migration step, and you need to then drag your migration here. Okay, so something which is important as well is like once you have your step function developed, right, you need to benchmark it. So if you go to benchmarking, right, you will see here like we are actually doing like a benchmark of this like a step, right? Then when you run the benchmarking, you see like here that result, okay, is what providing in the max step weight, which is used then for running the integrity test. So yeah, basically here we have the code. So basically we iterate, okay. In a certain point of the code, there is like this cursor, right? Like you see it here. Yeah. And then this is like basically used in the palette, right? When the migration is triggered. So once we have the step, right, the step function developed, here, for example, what we are doing is like we are reading like the old or the previous like amount of items which were not migrated yet. Okay, that's why, for example, we have this old module, right, where we define the old item metadata struct. Like this is like the one that is actually on chain. Okay, and then we use a storage alias to read and put like the items that are going to be migrating during the multi-block migration. Okay, and it's going to be put in this one, in this like a storage item. Okay, so yeah, this is very simple, right? Basically we read it and then we add the new values, the translated values in the actual metadata, item metadata, storage item, as you can see here. So this is like the real, I mean the new metadata item. This is not the alias. This is like the one that is on from the palette and is going to insert it, right? And finally, this is like basically returning, the amount of the benchmark, the weight, right, for this step function, which was previously benchmarked. So here I'm not assuming, I'm not like repeating the mistake I did before. I'm not assuming the weight. As we have benchmarked, this function, this step function, we are like basically returning, like the result of this, the real weight, like this step function is taking, right, with the amount of like read and write which involve this migration. And for example, if you see here, like there is this if statement where it's basically taking the amount, the last. So basically what here is saying is like if there are no more items to migrate, then we put we basically return the migration is finished, right? And this is like the weight that the last weight that this whole migration took. This one, I mean, this framework for the contracts palette involves like changing a little bit the code of your palette. So for example, you need to set the migration. You need to create a storage item on this palette, which is the migration in progress, right? So here you put the cursor. Okay, so in each like step function, this migration cursor is updated. Okay, and another thing that you need to do is you need to add a hook, right? And basically this is going to trigger an idle, right? So in reality, what happens is like when this is executed, this migration, each migration happening in the block, happens is triggered on the on idle. So when on during the available capacity from the block, there is where this migration is going to run. Of course, like if you do a maintenance mode, right, and you are not having incoming transactions, then this on idle would take most of the execution or the weight available for the block. Okay, and well, this is also doing the integrity test, and it's basically calling the migration. So here is where all the magic is happening, and it's calling the migrate. Okay, so before doing the actual migration, there is something I wanted to show you. And for example, I said, like you need to test this migration. The most important thing when you do a storage migration like this is to test it. All right. So one of the first things like we should do, okay, is for example, use try runtime. The try runtime detects like there is a migration that is going to happen. And this, for example, gives you the amount of ref time and proof size like this migration is going to do. Okay, it's like a rough calculation of all the steps, right? So if your migration takes like, I don't know, 20 blocks, this is going to give you the whole amount. And you can see here, like in this ref time is exceeding pretty much the ref time for the block. Okay, so it's this gives you the information. Then this framework that comes from the contracts palette is already taking this into account and is like splitting. But this is not like a way to say, okay, basically the try runtime passes, so this means like my migration is going to succeed. Okay, basically what you need to do the right way to test your migration is to basically get an instance or like a node, right? Like get like a separate instance, okay, of your chain. Like for example, you can similarly of how I'm doing it here, you can like start a parallel network with ZombieNet. Then you can do a snapshot on your real chain. You import that snapshot in this like parallel chain run with ZombieNet, and then you run the actual migration. Okay, so by using the try runtime, where you can see the values here, okay, and making sure like the whole migration finished correctly, and doing like this fork, and testing the migration with real data on a fork instance, I mean, you are like getting much closer in order to not break your chain. Something which is out of the scope on this for this presentation is how to unbrick your chain, how to recover. Okay, this is going to come in future deep dive sessions. Okay, because it's a lot to cover. Long story short, you need to, at this point in time, at the recording of this this session, right? You need to go to basically to the relay chain governance and ask for the unlock, right? And then you repair like the chain, okay, the chain state prior to the failed storage migration. Okay, so if we review a little bit the code right now, well, we went through like these steps. Function, I show already the benchmarking for this. Yeah, basically how to configure the runtime. So if we go to the palette Unix, right? So we provide here in a tuple, right? All the migrations, okay, like we are setting here. Something nice about this is like you can define like the sequence of migrations, right? So if you miss migrations, a lot of migrations, right, for a certain palette, a frame palette, in here you can put like all the migrations like needs to be executed, right? So let's suppose that I forgot to add my to add my migrations to a certain frame palette. So yeah, with this framework or mechanism, you just list them all here, and it's going to sequentially upgrade it. So I modify the palette Unix as well. Where is it? Yeah, here. I basically modify the Unix palette, right? The config tray, sorry. Yeah, to receive the migration sequence. This migration sequence is like, each step migration, the one like I share here. Okay, so then on your runtime, you configure, yes, the sequence of your migrations. Okay, so it's exactly the same process. You go to the executive palette and you basically set the migrations there. So sorry, I'm not like, yeah, migration. So let me find that specifically where it is. Yeah. So where is it? Is some part of here? I know how to find it. Yeah, here. Right. So you don't need to in this framework we are using. You don't need to in this part of the frame executive list all the migrations. Right. You just set a migration type here, and then in the palette definition in the migration sequence you list them all. All right. So yeah, I think like right now I already run the try runtime execution. So what I would do right now is like kind of the equivalent of running a fork, of my live change into my local instance with Subminet. All right. So let me see if this is the video. Yeah, no, this is the one. Yeah, basically I'm using videos because like if I have to during this this live session switch between restarting, switching, re-importing the state and so on, that it was going to take a lot of time. So that is the reason why I decided to basically use videos, right? So basically this is like an instance again before that failing migration I did before. And yeah, we can see here like we have the exact amount of values, right, for these storage items like we had before. So for example, we are collection 7, item 2000. So yeah, we have pretty much a lot of like items here. I will get another tab opened, and yeah, basically I will perform the upgrade again, but with the right migration. Okay. So I'm taking the second runtime. This runtime blob is the one that contains the correct migration. So again, we go through the same process. We authorize it, and we wait until the store validation function is applied. So yeah, I will. Yeah, it's here. We can see the upgrade. Yeah, I will forward this video a little bit. Okay, now the validation function is stored. So, and yeah, here we see that is applied. Okay, so let's go again to the logs and let's see what we got in the logs now. Yeah, there we see like we have the migration for the Palette Unix. It says upgrading storage from start version 0 to version 1. Okay. And here we start basically reading like in each block being produced, there is like this migration being triggered. Okay. And you can see in the left side, like the blocks are still being produced, even though like, this migration is running. As I mentioned before, I didn't like put this chain maintenance mode. So because we don't have enough time for doing all that. But do not forget to do that if your use case requires. Okay. So again, in each block, we are seeing like, there is this upgrade, going on. And we should see very soon the line which says like the migration ended up successfully. We see like still we have blocks being produced. Okay, so basically the chain is not stalled. Okay, let me forward this a little bit. Yes, right there. In this line, we said like all the migrations are done. Okay, so we have the confirmation that after a couple of logs, all the thousands of metadata for the item for the Unix items were migrated successfully. Okay, so now that we have that ready, we go to the change state. Okay, we check the Unix. Let's go into query for an item metadata. And yes, there we see like we have the new storage item with a new version and this like pre-filled value that we put. Let me just show you that part where it says like Polkadot did die. So this was the new value that we have added. Okay, so storage migrations is a super sensitive topic. Do not trust whenever that you need to do a storage migration. You don't be confident. Do not assume things. The conclusion we have is test, and test more. Okay, use try runtime, do a fork in your local chain, get the real data, and run your migration in your local environment until you make sure that everything is fine. So basically with this, my demo and the code walkthrough finished. But please be aware about all the things that are happening in this subject. For example, in Sub-Zero, there are going to be, more deep insights about like the multi-block migration. Be aware about when all these like activities are going to be merged and ready, because of course, once this is ready, this is like, what it has to be used. Okay, to make a migration. But at least in this like demo, being like the time of this recording, we got like a really good example of how migration should be done with this framework coming from the Palette contracts. Okay, now it's your turn in case you need to do a storage migration for doing it properly and test it and test it and test it and more testing after that. So from my end, I'm ready. So thank you very much for joining to these deep dive sessions, and we hope to see you soon.